So, yep, good evening. So, multicasting, we were we were looking into another topic called spats mode. In spats mode, we have an RP, and this RP need to be configured manually on every router. We saw that. Now, what if I want multiple RPs? What if I want multiple RPs? First of all, why do we need multiple RPs? To load share, to share the load. See, we know the role of RP. Rendezvous point is the place where the group members come and enroll and the sources come and register. Group members will know about the source through the RP, and then after they know the source, they will use the reverse path forwarding to find the shortest path to reach the source, and the multicast session will begin between the source and the group member. This is what we learned in the previous class. Now, if there is only one RP in the topology, then all the S, G registration happens to that one RP. What is S, G? Source, group member. All the group members, all the routers need to come only to that same RP from all corners, and all the sources should come and register with the same RP from all corners. That may cause traffic disturbance. That may also reduce the performance of our network. So to solve that, we can have multiple RPs in different part of our topology, and we will say RP1 will be responsible for, you see, when you see this picture, let me cut this picture so that I can. This is not ours. Yeah. So you see the multicast address here, 224.111, 112, 113, 224, 222, 2223, 224. Now, our idea is instead of we having only one RP for this receiver, sorry, for this source and this source, instead of having one, we can have two. So one RP will be responsible for those group members that belong to this multicast. Maybe this one. There will be another RP which will be responsible for these group members. So if you have a receiver to this group, then this will go and enroll only to this RP, and the registration will come, and this receiver need not to go towards the left hand side. Likewise, if this receiver needs signal from this group, it will only go and register with this RP, and the multicast traffic goes between source A and the receiver in the left. So, there is no much traffic in this side because the load has been balanced. You see, so splitting the load, or this receiver may be, this receiver may need some traffic from both this one as well as this one. It's okay, but for this particular second address, it'll go this way and register and get the traffic, and for the another one it will go and register with this one and get the traffic. So instead of having a single router for all multicast, if you have many multicast, groups. Instead of having one single RP, I can have multiple RPs and say this RP will be responsible for these multicast address, whereas the other will be responsible for other multicast address. That's the best way. Now, not only this router, you will configure even on this in this router, transit routers. You need to tell, hey, transit router, this is the policy. For these multicast groups, you need to go to RP1. And for these multicast group, you need to go to RP2. You have to configure the similar configuration in all 4 routers. In the previous class, we had only one RP, and that one RP address we were cutting and pasting on every router. So that one RP is what going to be responsible for all the groups. All the groups starting from 224.0.0.0 to 239, 255, 255, 255. Yeah. So instead of putting more pressure on one single RP, if you have more RPs, if you have more multicast groups, you can create more RPs. Configuration part is simple. You see, let me show you. You see, this loopback address, if you see, this is the IP address of RP1. 222 is the IP address of RP2. So in RP1, we are doing this configuration, okay? In RP1, we are saying IP multicast routing. This is to enable multicast services. And then we are saying, for those who matches with the access list 2, this is the RP. For those that matches with this access list 3, this is the RP. You see? So this is the access list number. This is the syntax. In the previous class, we just stopped up to here. We did not put this number. When you don't put this number, then it means for all multicast group. But here we have a specific group to access a particular RP. Right. Next is, see, this configuration is in RP1. And RP2 also, it will be ditto, same configuration. Not only on RPs, even on the other routers in the topology, it's going to be the same configuration, no difference. 3 and 4. You see, so you can use an access list. I don't think we need to do this. Right, it's very easy. You need to pick some routers, like what you see here in this picture. One will be RP1, another will be RP2. And then we cut and paste the same access list and same configuration on every router, including RPs. That's all. Any question on this multiple RP scenario? Splash mode with multiple RP. Ask me a question, take your time, think, and if you have a question, you can ask me.
The only thing I want to ask is the RPF.
Reverse path forwarding. Reverse path forwarding is nothing but once the group member know who the source is via RP, it will see the routing table how to reach that source. And using the routing table's route, it will go to the source and say, give me the multicast feed. And then the traffic flows to that requester by using the same shortest path according to the routing table. That's what called as reverse path forwarding. It's nothing but reaching the source using the routing table. Simple routing, but why it is called as reverse path forwarding? Because the source initiated the session, source went and registered with the RP. And RP gave the information about the source to the group member. And group member says, okay, now I know the source, let me go to the source and ask him for the multicast packets, feeds, for which it uses its shortest path in the routing table or whatever the path. It may be shortest path or depending on your routing protocol. It uses simply the routing table to reach the source. On the path, there may not be an RP. RP may be in some corner. RP has given the source. Once you know the source, you don't need to go through the RP always. That's what I was showing you in the previous class. This is why it is called as reverse path forwarding. You are not forwarding via RP always. You are forwarding via the path which is feasible between the sender and the group member, for which you need to find the shortest path, the best path in the routing table. Only then it is going to be the best path. Otherwise, going through the RP may not be a best always. RP may be in some corner. Always going through RP is not good. Please ask me a question if I didn't answer your.
Sure.
Yep.
So it uses its own routing table to
Yeah,
find the sources
correct.
and then
After
reaches the path.
after knowing the address of the source, it uses its own routing table to find the shortest path. It may be via RP, it may not be via RP.
And does this concept apply anywhere else? Like, say, this is multicast, so it makes sense to do a reverse path forward to the source.
Yeah.
Like any other setup, like which does not have multicast, is RPF used?
Yeah. Of course, in security, in the world of security, we use RPF. All the firewalls will do RP or reverse path forwarding, RPF. Firewall wants to know that the packet has come from exactly the same path which it knows in the routing table. You see, there is a packet coming from somewhere. Now, before forwarding the packet to the destination, firewall will check whether the direction in which I receive the packet and the direction what my routing table shows for the source is same. Only then it will accept the packet. See, usually routers will never do this. Routers will see the destination and route the packet. Router will see only the destination of the packet and route the packet. But firewalls, before forwarding the packet to the destination, it want to evaluate the source. So it checks the source address of the packet, and the packet is received on gig Ethernet 0. Now it will check whether the routing table also shows gig 0 to reach the source. If yes, only then it will use the destination and forward the packet to the destination. If not, it will drop. Did I answer your question?
Yes. Okay, so basically, it just checks for like the first half.
It checks the source.
Direction.
Yes.
Source. Yeah. Okay.
Need not be first hop. Maybe if many hops will come from inside and it's going to go outside. So it will check the routing table. That's all. Routing table will not only show first hop, it will show many hops. Okay. Any other question? All right, if no question, let's move on to the next topic. Thank you. Next question is our next topic is auto RP. You see, when you have a router as an RP, so for example, router 1's loopback 1.1.1.1 is RP. This you need to announce to everyone. This we need to announce to everyone by manually going and configuring, which is not scalable in a large network. You cannot going to every router or put RP. What if RP changes? You need to go to every router and delete the RP configuration and put different one. That's not friendly, It's not okay. It's not friendly. So we need RP to be discovered dynamically. We want RP to be discovered dynamically. How? How RP can be discovered dynamically? Unless someone announces, you cannot discover. Correct. Unless someone announces, you cannot discover. That's the truth. Unless someone announces, we cannot discover anything in life also. Our eyes won't see unless someone reveals it to your understandable language. That's why we look into God for all help. Our eyes should see. Otherwise, right in front of you, there will be a big blessing, but your eyes will not see, you will not be using it. Yeah. Unless someone announces, discovery is not possible. Likewise. If every router needs to know who the RP is, there is need for a flooding method to announce RP. So you announce flooding information saying, I am an RP, I am an RP, so that everyone will know RP. For which there is a need for a special multicast address. In Cisco, two addresses are received for announcing and for discovery. 224.0.1.40 and 39. I showed you the other day when I was typing show M route. There was one multicast group without V enabling it, it was already there. That is what Cisco's Auto RP group. Only on Cisco router you will see that. So Auto RP uses a dense mode to announce and discover RP. After that, they will switch to sparse mode once they know the RP. Now, how does the configuration go? This is how it goes. Let's say router A is the RP. Router A is the RP. Okay, so we say IP pim send RP announce, and then the IP is loopback 0. Scope, how many hops you want to advertise it? How many hops you want to advertise, announce? 16 or 5 or 16 is the max. Likewise, how many hops you want this to be discovered? From how many hops away? Send RP announce command, send RP discover command. We type. If the announce command and the discover command is on the same router, you don't need to repeat this loopback 0 interface. If it is on the different router, see, one router can be an announcer, another can be a router which helps to discover. Meaning, let me repeat again. See, In this example, router A itself announces and router A itself sends the discovery packet to everyone. But you can also separate this function. Router A will announce, hey, I am the RP, but the next router where you put this command, discover command, it will propagate it. So a propagating router and the announcing router is on the same router in this example. You can keep it in different router also. These two statements can be in different router. If it is in different router, then you need to give that router's loopback interface here. Alright, so whereas on the other router, see, that is on the RP router. This is on the other router. See, on the other routers, you don't mention anything about RP. You just say IP multicast routing. That's all. Very simple. IP multicast routing. Then why do you put sparse dense mode? Listen. Why do we put sparse dense mode? Because to discover auto RP, initially auto RP will use dense mode to flood the information about the RP. Once everyone learn RP, they will switch to sparse mode. Is that clear?
Yes.
This is what we are going to do now. Let's do. So this is the command to remove the previous RP configuration on every router. We configured it statically. And also I have sparse mode on all the router. I want sparse dense mode. So that also I'm going to remove. On R1, I removed RP, but I did not remove this one. So I'm going to remove this as well. Interface range F0/0-1, comma F1/0-1. Why I'm putting -1? Because in router 3 I have 4 interface. So 4 interface. If I remove from all routers, it's okay. Now done. Instead, I'm going to say IP pim sparse dense mode. That's all. I'm going to put it on R1. Let's verify show IP pim interfaces. You can see SD. SD stands for sparse dense mode. Okay, even on the loopback, I would like to change it. Even on the loopback. Wonderful. All the interfaces are SD, sparse dense mode. But show IP pim RP. You don't know about RP. Okay, now I'd like to paste this on every router. All right. There's only router 7 up to 7. We finished removing and putting the new configuration, but none of the router knows RP. Show IP PIM RP, no one knows. Now what I'm going to do is, I'm going to make R3 as both rendezvous point announce and discover router. See what happens. Right now show IP M route, multicast route. You see this multicast address? This is to discover. To announce 1.39 will be used. That you will see when I finish configuring RP. On R3, show IP M route now. You don't see what? 1.39. But now when I say IP PIM RP announce, no, IP PIM send RP announce my loopback interface, means loopback 0, which is 3.3.3.3. Scope is optional actually. If you don't say any unlimited, you can say like 10, or I don't have too many hubs here. Even if you say 3 hub, it will be more than enough for your topology. This is for security reason. You do not want your RP to be informed to attacker in the outside world. Next. Now I would like to say do show IP PIM M route. Not PIM. Do IP show IP M route. You see, this is what I was talking to you. 1.39. So only the announcer, only the RP will use this address and say, hey, I'm the one who is owner of this RP 3333. Now the discover command is also important. Discover, again you can put the same loopback interface, or otherwise it will automatically take you for the same router. Scope is not mandatory, but it's okay. Now that's all. You will see the magic. Let me take you to R7. R7, earlier it was not knowing about RP, but now it knows about RP. Look at this, it knows the RP. Now let me show you show IP M route. Again, show IP RP address, PIM RP. Let's join a multicast group, then you will understand. Let me join interface loopback 0 IP IGMP join group 239.7.7.7. Now you will see. You see RP? It knows the RP. RP is this address. For this group address, I'll go to this guy and register. You see? Dynamically RP is discovered. For that, it was using dense mode to flood this information. You see? Because we have configured sparse dense mode, it can flood the information about the RP. And later it started pruning because there is no one to receive. Whereas on the other interface it's forwarding. Anyway, that is auto RP. Again, this is a Cisco proprietary. It's only for theory we are learning. I don't think anyone will use this because we don't like dense mode. To avoid dense mode only, we went to sparse mode. Now again, using both dense and sparse, it's not okay. Right, so fine. Anyway, we have to learn this once at least, so we are learning this. Let's move on to the next topic. What if I have multiple RPs and you want to use auto RP. Same, use the access list. You see here. Similar like what we did earlier. Only thing is you need to use the access list in the announce command. And you are taking the ownership for all multicast here, 239 on all multicast. Means beginning with 239, not 238 or 224. Right? On the other routers, nothing. On the other routers, nothing. No changes. Okay, this is multiple RP, right? Okay, multiple RP. First RP is taking responsibility of 239, and second RP is taking care of all 224 except, sorry, the complete multicast except 239 CD9. So 239 RP is RP for multicast 239. Beginning address group member is RP1. For the rest, all multicast like 224 to next 15. 224 to next 15 is what? 239. If you start from 224, it is 228. So anyway, deny statement is in the top. So 239 will be denied. All the rest is going to be permitted in RP2. Is there any question on multi-RP? Please ask. Auto RP, multi-RP. Any question on auto RP with multiple RPs? All right. Just a big sound. Anyway, what is going to be next is we are going to learn BSR, and BSR is one fine method of discovering RP using PIM. We already have PIM, so you don't need another protocol like auto RP. So we are going to learn BSR. We are going to learn MSDP, Multicast Source Discovery Protocol, and Anycast RP in our next class.